Today I'm going to take you through a lesson on how to simplify radical, or in particular, square root expressions. Just like how we always have to simplify ratios or fractions down to a simplest form, radicals also have a particular set of rules for us to get us to a simplest form of their answer. To get a square root down to its simplest form, there are three rules we're trying to follow. An expression involving square roots in its simplest form, or is in simplest form, if there are no perfect square factors in a radical, no fractions appear inside the radical, and no radical appears in the denominator. I'm going to go through some examples that in particular make sure this first condition is the one that is met. There are no perfect square factors underneath the radical. Remember that when we're talking about perfect square factors, we're talking about numbers like 1, 4, 9, 16, 25. These are called perfect square numbers because I can take some number and multiply it by itself and get one of these numbers, and they're also then, when I square root them, they end up being a natural number. So if I have a number under a square root that has any of these factors, in particular the ones bigger than 1, 4, 9, 16, 25, 36, or anything bigger than that, there is a way to simplify this square root down to a simpler form. I'm going to show you how to do that right now. First of all, just showing you some examples of numbers that can't be simplified anymore. I've got some on the left side here, like square root of 17 and square root of 13. These numbers are prime and don't have any perfect square factors, so these are as simple as they can get. They are in the simplest form they could be. Another example would be something like the square root of 35. Square roots can be broken down into the factors that make up that number. For example, the square root of 35 is actually equal to the square root of 7 times the square root of 5. Since neither of these numbers are perfect squares, the square root of 35 is in simplest form. This is as simple as we can make that square root. When we break square roots apart like this, we are looking to see if they have perfect square factors. That is when we can simplify them even more. So now to look at some of these square roots that can be simplified more, let's take a look at the examples I've got here on the right. Square root of 12. We can simplify this square root down more than what it is. The square root of 12 has a couple different sets of factors, like 1 and 12, and 2 and 6, and 3 and 4. When trying to simplify square roots, you should try to pick out the factors that have perfect squares. For example, I see that 4 is a factor of 12. So when I break apart the square root of 12 to try to simplify it, I like to tell my students to try to pick out the factors that have square roots like this, or perfect squares like this one. So I can break apart the square root of 12 into the square root of 3 times the square root of 4. Why this is helpful is because the square root of 4 is actually just 2. So now I can say that square root of 12 is actually equal to the square root of 3 times 2. And when we write simplified square roots, we usually put the number on the very front, or in front of the square root, kind of like a coefficient in a variable. So I would write this final answer as 2 square root of 3. And that would be my final answer. That is actually equal to the square root of 12. If I punch that in the calculator, if I punch in the square root of 12 in the calculator, it'll be the exact same as what I'm punching 2 times the square root of 3. They are equivalent, but this is my simplified version of the answer. Let's do another one like this. We'll look at the square root of 75. Again, 75 has some different factors. I'll list some of them here. Kind of like 1 and 75, 5 and 15, and 3 and 25. And the one that I actually want is my last one here, 3 and 25, because 25 is a perfect square factor. So again, I could use some of the other ones, and there are still ways I could get to the answer, but if I'm going to break this apart, square root of 75 is equal to all three of these versions, but I'm going to use the square root of 3 times the square root of 25. Because now that I've picked out the perfect square factor of 25, the square root of 25 is actually 5. I'm going to take that and put that in front of the square root of 3. So when I write my final answer, square root of 75 is actually equivalent to 5 times the square root of 3. And there's my simplified answer. Square root of 3 isn't a perfect square, and so this is as simple as that square root can get.